Hello and welcome to another video. Today we have something special. We have from Paul a letter. I've sent a Gigabyte Aorus X570 Elite. It responds to the power button and I get fan spin, but no display and even from the onboard HDMI port. I've tried reflashing the BIOS with no change. Different RAM, different CPU, PSU, all the usual stuff within my skills. If it won't give any beep errors with RAM and GPU remove also. And the power switch does not respond if CPU is removed. Not sure if that is normal or not. That is normal for AM4. I can't see any missing components. The owner advised it just turned off during use and would not power back on. Thanks, from Paul. So interestingly enough, this board belongs to a kids charity, and this has a BitLocker on it. And only with this board they will be able to get their data back, if I understand him correctly. So, yeah, this is something special where we really need to try to make this board work again. Interesting kind of PC that they have with such a high-end Asus board. Yeah, so I have no idea what is wrong with this board, because they just said it just turns on and turned off. And now it just turns on, but with no response anymore. I can already see one of the CPU pins, one of the fan header pins is bent, as you can see right there. I can already feel that this heatsink is loose. This one is tight. He said he flashed the BIOS, so we might want to make a clean BIOS flash ourselves. And I wouldn't expect there to be any knocked off components, because they said that it just turned off during use. So let's first see how the passive power consumption is when we have a CPU plugged into here. So we're going to go for 2200G. And let's see how this board will behave. If we can already see something by the passive power consumption, and also see if there still is a reaction to the power button. And let's also plug in the DDR tester. Let's get some DDR4 RAM also into here. And also let's use a postcard. Normally I use a TPM header, but on Gigabyte boards, sometimes it is enough to plug it into the main PCIe, because there's no available TPM header here anywhere. Oh, there is one, but I don't think we can connect to that one. So there's the QFlash Plus button. We might want to use that as well, because there's no header to connect to this BIOS chip, but there's also nothing close to it. So we would be able to just take it off with hot air if needed. So let's get a speaker also onto here and a power button. And let's now turn on our power supply. We have 220 milliamps. That's kind of high, to be honest. That's higher than I would expect it to be. Okay, let's see. Does this have any debug LEDs? I cannot see any. Really, such a high-end board does not have any debug LEDs? That is weird. Because you need to imagine this is an X570 board. No debug LEDs as far as I can see. Well then, let's turn it on. 2.1 amps. So we have 2.1 amps. We have a reaction to the power button, but we get absolutely no postcodes. It says D0 on here, which means that there's nothing, and there's also 00 on this one, but PCIe reset isn't stuck. But I think the CPU is not being initialized. So question now is why. I think there might be a missing RAM voltage. That could be one of the cases. So what we can do is let's get the voltage tester for DDR into here. So let's see now. For the voltage tester, we're going to be turning it on. Let's see if we have all of the voltages. And it seems like, oh, SPD is kind of low. SPD is normally supposed to be like 3.3 volts. That is weird. Why we have such low SPD voltage. So let's dig into that a little bit. But it's 2.5 volts. Could that be the reason? Normally SPD is connected through a fuse or poly switch or 0 ohm resistor to the 3 volt line. This time it's pretty close to 2.5 volts. So on this board, it might be just connected to the VPP. So that SPD is just connected to the VPP directly or through fuse, and that's why we have 2.5 volts. But in order to check that, we need to go into a board view to see if that is correct or not. So let's see. Now we are in a board view. We go on any of these slots, or we just can in nets just search for SPD. VPP SPD. Yeah, okay. If it's already called VPP SPD, I would be expecting that it is connected to VPP. That would explain why it's 2.5 volts and not 3 volts like I usually know it. Let's see, there's 1K ohm resistors. Are these connected directly to... No, these are not directly... I would expect them to be connected to the VPP, but they are not. So I cannot see where this is connected to VPP, because we have 4 connections right here, which is all the DDR. We have 4 capacitors. Then we have 4 1K ohm resistor that are just connected to a different pin. And then there's a not fitted one that is connected to VPP memory. This might be, yeah, this might be just a solder bridge. We would have to look at that. But if it's called VPP SPD, I'm pretty sure that that is normal. That is like it's supposed to be. And there's no other SPD signal. There's an SPD IF, but that is something for the audio. And the other one, SPD0LC. Oh, this is for the Ethernet connector. Or for the driver of the Ethernet. So SPD being 2.5 volts is fine. Okay, I want to try a 3000G in here, just to be sure, because I'm not too sure if the 2200G is supported in this X570. So let's see if we have a different reaction. We just have a very slightly higher power consumption, but that is due to the CPU. So this is just a little bit more hungry CPU. That shouldn't matter. Let's see for the voltage of the battery. So let's see the voltage of the battery, and we have 3 volts. So the battery is pretty new, so that isn't a problem. Let's now try a quick reset just to be sure of the BIOS. So the battery is out now. Let's see, is there a clear CMOS header anywhere to be found? But I can't find one, so I will be just draining the battery contacts like that. But no clear oh, there might be one. Yeah, here, clear CMOS right next to the power button. So that is done. Let's try it again, just by the off chance. But no, still the same. I would now want to go over into doing the BIOS flash with the Q flash, just to be sure that that is not our problem for now. But before, I want to see if vCore is present on this board. So if we have the actual CPU activity, so let's see. Yeah, we have 0.9 volts. So vCore is definitely present. I would be very interested in seeing if there's any knocked off components anywhere, because we mostly have our voltages. Like if vCore is running and we have no CPU initialization, it's either a BIOS issue or some small signal that is missing. So I would be going over this board now to see if I can find any knocked off components anywhere. Especially on the back side. and I will need to take a closer look at the SIO area, which is also under this big heatsink. So let me first go to the backside and see if I can find any damage. So one of the corners of the board has been chewed off. As you can see, it has quite some damage, but it's only on this side and there's nothing really here that can be damaged. So this shouldn't be a problem. And would you look at that? I didn't search for long. I wasn't even a minute into this and I found that. That resistor is dead. Like, that was thankfully very obvious that that resistor isn't where it should be. And not only that one, but one more looks kinda iffy. Like, this one is obvious. And question is this one damaged also? But I don't think so. I think it only hit that one. Yeah, looking from the side, it definitely only hit that one. So let's see what this controller is for, and why this could be a problem. I've had it before on in a very similar area, that there was a controller that prevented boot up. So that there was a controller for boot up failure that pulled the board low to not start up when not all of these signals were there, if there were missing power good signals. So let's see what this controller is for on that resistor. So now let's go into the backside of the board, and we need this controller right here. ISL6617AFRZT. This is part of the PWM controller of the circuit. And obviously, what is missing is its VCC. So there's another pin where this goes for the capacitor. So the VCC for this pin is missing. And this seems to be PWM controller for V-Core. So this is connected directly to the PWM controller. This is probably one of the inputs, just like this probably is an input. V-Core A1, where does this go? This goes also to capacitors on that side, to a 10 ohm resistor, and that 10 ohm, oh, this is for iSense. Got it. This is for sensing. Yeah, and this whole controller won't work without the VCC. So let's see what else this one does. This is just a direct connection between them. Let's see, the fourth one is probably also eye sensing then. Yeah, this is also for sensing. Let's see, the fifth signal going to be the same again probably. 15k ohm. And this goes, oh, this goes to also to the PWM controller almost directly. Let's see, is there anything more indicative of what this does? PWM B1, where is this connected to? And this is for one of the so it also drives one of the MOSFETs or DDR MOSFETs that are installed here. And it does that even for two. So for another one there. Interesting. And then there's more of the eye sensing. So some of the phases are not running properly, and that's probably why our board isn't starting up. So this would be my expectation. And we just need a 10k ohm resistor, so nothing special. So let's get a 10k ohm resistor soldered into there and then see if we have any change. So let's get rid of that resistor. For that, just taking the soldering iron. Let's get some flux into here. So flux into that resistor. We're going to be getting rid of that broken resistor. Thankfully, it's a very common value with 10k. So making sure our soldering tip is clean. And now let's go onto here and also this side and get the resistor off of here and out. Let's get some fresh solder on here. And now let's take a new 10k ohm resistor and drop it onto here. There it is. And what I always like to do is I like to get it into position, like right there. Then get my soldering iron and just tack on one of these sides. So going on one of the contacts and trying to pushing the resistor into place, not burning the resistor up. Like that is enough. And now what we can do, it makes it very easy to just take the hot air, blast the area, and just get that resistor into place. I have a huge nozzle on right now, so I hope I don't blow this just away. And it flinked off. Great. Man, that happens too often to me. I pinch stuff too hard sometimes and then stuff just flings off. I need to be more careful with this. Luckily with this resistor I don't care. I can just take the next one out of the line. So doing that once more. So that is connected. Once more, flux. And now heating it up again. And now pushing the resistor a little bit back and forth. So we know it's definitely connected. And now, as long as the area is still hot, getting some Q-tips into here and some IPA. And getting rid of all of the flux, cleaning it off nicely. So, area is nice and clean. Let's see if that is enough for our board to turn on now. Because this really wouldn't fit the description of it just turned off from one day to another. So, because this could have happened while it was in a repair shop and it was tried to be repaired already. But let's hope that this was all that this board had. So, now I'm interested how this board will behave if that was already enough for us. So 190 milliamps. Let's try to turn it on. 2.3 amps. That doesn't seem like it helped at all. So there's no startup, but this might still be because of the BIOS that has been flashed. I will have to confirm that there's a there's a good BIOS on here, and there still might be more damage. So this might not be the only damage that occurred to this board. So let me look further for any more physical damage. And if I can't find any, let's go over to the Q-Flash. And if that also doesn't work, we might have to confirm the BIOS via taking off the BIOS chip and making sure that there's a good BIOS on there. So let me have a look once more at the backside of the board. So I wasn't able to find any more damage. So what I want to do now is to get this BIOS chip off of here. So we're going to be doing the usual of applying some flux. So now I want to use the Q-Flash button on here just to be sure and see if that works. So turning on the power supply, and I have a USB thumb drive in there now. Now going to go ahead and press the Q-Flash button. Let's see if this reacts now. And the indication on my thumb drive has started. So there's an LED blinking, but there should be also another one blinking right here. If this actually is working. But we do have high power consumption, so the board definitely did start up. As you can see, we have 700 milliamps now. So question now is, why do we not have the indication via the how is it called? Via the LED that should be blinking. The PCH is getting way warmer than I thought it would get at this stage. I do have the heatsink removed. Let me get a small heatsink to put onto here so it doesn't overheat. Let's get, yeah, this should be fine. There's a big thermal pad on it. Should be fine. So it does have current consumption, but I would expect that the Q flash would be running, so that the LED there would be running, because I think the manual said that that is an indication that it's actually running. The power consumption is kinda high, to be honest. I wouldn't expect that high of a power consumption when just doing such a standby flashback. So I cannot get the Q flash to work on this board. So I will be using my programmer and this adapter to put the BIOS chip onto here. And then we will try it like that, because the Q flash just refuses to work. Like, it does turn on, the power consumption goes high, but the LED, there's no indication on the LED, and the board never does anything anymore. I've tried with different BIOS versions, and with different USB sticks, but it did not want to work. So we're going to go the manual way of desoldering that chip and seeing if that can help. So now the chip is on the adapter board. So let's go over to the computer and try to flash this. So now on our flasher, connecting the programmer. Let's see, this should be a 1.8 volt chip. Let's see, the identification is not being read out. Let's see, let's confirm that this is a 1.8 volt chip. Yeah, it is a 1.8 volt chip. Okay, I will either have to do some resoldering or do some reconnecting. Let me do that for a second. So after quite some back and forth, I was not able to get the chip to be recognized. I now took a replacement chip and only soldered it on the exact same way, and the replacement chip instantly gets recognized. Like, if you read the identification, it shows the chip, and let's just the 73F, this is the one. So it seems like that the previous BIOS chip might have been faulty, because I just couldn't get a readout. I resoldered it 2 or 3 times. Even tried with the CH programmer, but I didn't get anything. Yeah, and this one just soldered on the exact same way. This one works without a problem. So it might have actually been that our previous BIOS chip has been faulty. So let me quickly do the BIOS flashing onto this. So I've now flashed the new BIOS chip, and let's now get off the old one. Or not get off the old one. I have flashed the new BIOS chip. Let's get it off of the adapter board and let's put it onto the board, because the old one was already off. So I think that should be fine. Let's have a look under the microscope that the soldering is properly. So the left side looks quite good. The right side also looks fine, but I just want to get a little bit of flux onto here and see that these are properly on here. Everything's on, and yeah, this should be it. The new chip is on here. Let's clean up a little bit and hope that this will work now. So Let's now see if anything has changed. Let's just see if it works. It should complain about RAM now. And does not work. That is not great. We have 2.2 amps of power consumption, and it does not go as far as to complain about RAM, as far as it seems. So there's no difference in plugging in RAM or not. So also on the indicators, on the pulse indicators, there's nothing. The CPU does get warm, but it seems like our BIOS is not being accessed. That is very weird. So let's try to check some of the voltages on this board. I want to go especially around some voltages of the PCH. So the BIOS battery still has 3 volts. It will show minus because I have the leads reversed. This is 12 volts. This right here is 1.2 volts. This is 1.05 volts. This is also another 12 volts. This is 1.8 volts. This is 0.9 volts. 2.5 volts. So pretty much everything is here. All of the voltages are working. I feel really damn stupid. If you've been paying any attention to what I've been doing before, you must have been screaming at your monitor that I did something wrong when trying to solder on that BIOS chip. Because, have a look now at the tester. And if we now press the power button, oh, the software is dead. 1 second. So, have a look at this. We have postcodes. We have 3 amps of power consumption. And it tries to boot. We should be getting a post beep every second now. So let's get a post screen into here. There's a post beep and there's the post. If you haven't guessed what I've done wrong, I've bloody soldered on the BIOS chip the wrong way. I've just put it 180 degrees around onto this board. Let me show you under the microscope. If you can see it right now, the dot is in the bottom right. I soldered it on with the dot in the bottom left, top left. And you can see the arrow in the bottom right there, which indicates pin 1. I've just bloody put this thing on the wrong way. That is... I wish I could say that's the first time that happened. But it's not the first time that happened. Yeah. Well. Now it's working. So. Now the board is working, it's turning on, and it seems like all this board has was a dead BIOS chip. And we were able to confirm that because this chip wasn't working with just putting onto the adapter and then putting it into BIOS programmer. So something is very weird. It just died, the BIOS chip. No idea why. But the big problem now is the board might be fixed. But if I'm not too sure where the Bitlocker thing is being stored in. Because pretty sure that it can only be the BIOS where the Bitlocker stuff can be stored in. And the BIOS chip is dead. Like, there's no way of retrieving data from this. This thing is not responding. I will be sorting it onto there once more and I want to see, but you can clearly see that the BIOS chip is probably just toast because I changed the BIOS chip and all of a sudden the board works again, which is a big shame. Like, just looking for fixing this board, that's great. Like, we got a really easy fix because these BIOS chips are like, what, 2 quid each? So, basically nothing. But looking for the BitLocker, Windows is not going to be recognizing this mainboard, I think. Pretty surely. Yeah. So I will be seeing if I can read out the contents of that chip, but pretty sure I won't be able to because I've tried before and it didn't react. But I hope you still enjoyed the repair. You learned something, because I'm not going to be testing this any further. There's nothing more to test there. It was actually just a dead BIOS chip. There's going to be everything working now, and the one knocked off resistor, but that might have happened while disassembly, so I'm not too sure about that. I think the original problem is actually the dead BIOS chip that is on what was on here. So I hope you learned something. I hope you enjoyed the video. All of my tools are linked in the video description. Thank you very much for watching, and goodbye.